In this video, we'll be integrating from -2 to 3 of x+1 dx using left-hand Riemann sums. First, we're going to use a definition. The definition says it's a limit as n approaches infinity of a sum from I equals 0 to n minus 1 of f of a plus I times delta x multiplied by delta x. And here delta x is just b minus a over n. So if you look at this integral, the function is whatever's inside the integral, which is x+1. A is the bottom limit here, is -2. B is the top limit, which is 3. So for delta x, we do 3 minus -2, which is 5, and that's going to be all over n. So now we're going to replace the a with -2, the delta x with 5 over n. So we have to evaluate f of -2 plus I times 5 over n, and we're just going to plug that in for x here. So it's going to be -2 plus I times 5 over n plus the 1, and then multiply that by 5 over n. The next step, we're going to simplify. So we have a -2 over here. We're going to add that to 1 to get -1, and then we'll leave everything else the same. Finally, we're going to distribute this 5 over n. So 5 over n times -1 plus 5 over n times I times 5 over n. So we'll get -5 over n plus I times 25 over n squared. And now we can simplify this. So this sum depends on I. So -5 over n is basically a constant. So you're just going to be adding -5 over n when I equals 0, I equals 1, 2, all the way up to n minus 1. So really going to be adding -5 over n times. So that's going to be -5 over n times n. And then for the second one, really you have the sum from I equals 0 to n minus 1. And then the 25 over n squared, because it doesn't depend on I, you can treat that as a constant, which means you can factor that out. And so you have 25 over n. And for this one, it's going to be n times n minus 1 over 2. And the idea here is you take, well, if I write this out, it's this. So this sum. And the idea is you pair up the first and the last to get n minus 1, the second with the second last, n minus 1, etc. And for that, you're going to have n over 2 groups. So you're basically going to add n minus 1 n over 2 times. So that's where this formula comes from. And so that's what we have over here. Now I can cancel out the n's. So the n's will cancel, and then we'll have -5 plus 25n squared times n minus 1 over 2. Now I'm going to switch the n squared and the 2. And so the limit as n approaches positive infinity of -5 is just -5. And then this will go to 1, since think of this as like, in the long run, you know, this is n squared over n squared, which is just 1. So it's 25 over 2 times 1. And when I add this, I get the answer is 15 over 2.